Hello there. So at this point you would have completed your circuit, you would have plugged it up to your form of power, and the lights should have flashed around, and we would have fixed any mistakes. And now at this point we are going to find a way to simulate our circuit on some sort of software to gain some more understanding of electronics and electrical components. So why do we do simulations at all? Well, there's several advantages. For one, we can't actually see the electron flow when we plug in our circuit in real life, and sometimes seeing the actual path that the electron takes through a simulated circuit can give us some increased knowledge and understanding in a particular circuit. And most circuit simulators will show the direction of the current and show like different speeds that it moves, and we can see graphically the difference between voltages and other factors such as inductance, which we'll learn at another point. But we can see it graphically and pictorially, so we can understand that better. Secondly, we can use it to do calculations for us. We know that we're going to use Ohm's law as the basis of a lot of our electrical work and theory, and most applications, if they're simulating the real life, means they should also be simulating Ohm's law, and so we can use that as a quick way to do those type of calculations. And thirdly, which is an elaboration on the second point, is we can use the fact that the circuit should be simulating real life. We can make multiple circuits or make adjustments to the circuits with simply changing numbers around in like a chart somewhere. So instead of having to physically solder different resistor sizes to measure different voltages or different currents going across components, we can just physically change the numbers and we can determine what the ideal resistor is for a particular circuit. So how do we do this? The app I would recommend over here is Falstad. So falstad.com/circuit and slash. I will post the link in the description. When you plug it in, you'll get to this sort of landing page, which will show an example of a circuit running. Yours might already be moving in this sense. We don't have to worry about this so far. This is just the example one they show. But as we scroll down, we see here there are some useful information, such as there is a full screen version. That's relevant because if you want to use this on a browser, now I'm using Google Chrome. In this example, I know it works on that. Obviously, depending on what updated version you're running of Chrome, could change multiple things. Apart from that, yeah, so if we do the full screen version, it's going to be larger, and so you won't have all this information at the bottom. It gives you a larger amount of working space. If you're also dealing with a scenario where you don't have a constant and reliable internet, you can download the standalone version. There's one for Mac and one for Windows. I'm going to be doing the rest of the tutorial on the downloaded version for Windows, just so I don't have to rely on having to have an internet access while I'm streaming this information through. So if I download it, you get the zip files over here. You open that up and you run the executable, and it should load up. The app should be running. Over here, other information, we have more index of circuits examples. So it's going to help you if there's a particular circuit you want to know. Like for example, you might be using a 555 timer at some point. There are examples of those circuits already in the simulator, so you can look at that index and there's going to be some information of it. And you know, if you want to see the Polish version, go for that if you want. So let's go and change my screen so we are looking at the other version. Let me just load that up. Alright, so over here, this is the version of this over here is the version of the app running on my computer. And I've just largened it up to be like a larger part of the screen. There we go. So it takes up the whole screen so we can work on that. So over here we have our standard buttons where we have our file, we have our edit, draw, scopes, options, and circuits. Our file, again, it's like your standard thing that you'd expect, where you can open new files, you can save files, you can save things in text format. If you have a Dropbox, so if you're doing like a team project with other people, or if you want to store your file online somewhere, you can get access to it from that. You can also use Google Drive. It's whichever way you want to save your circuit. Your editor is your standard copy, paste, duplicate, those things. You can also select multiple parts. Put the circuit in the center of the drawing. You can also zoom in and out. Draw, this is where we're going to be making most of our components. Over here we have like adding wires, adding resistors. That's actually how we're going to be building our circuit. Scopes is just a way to show how these are visualizing. Don't have to worry about that. Options, again, this is just showing how we might want to change it to a white background. I like to be super pro and keep it at black, but also saves, electricity, I guess, because you have less light shining on objects. Next, we have our circuits. This has a whole list of pre-done circuits. So you see there's a lot of circuits. Now, actually finding the circuit you want could sometimes be difficult. You may need to do a Google search, but like for example, our 555 timer is used for more advanced circuits, and we can already use our 555 timer example to generate a particular circuit. So this is where we're going to start. Over here at the bottom of the circuits, we see the blank circuit button. We click that, and we should have a screen that is mostly blank. We're going to have a little indicator down here, which is just this is representing like our this is representing the values of wherever we're putting the mouse. So when we're going to be running a circuit, if we have a component, if we put our mouse over it, it's going to be loading up the results over here in the bottom right hand corner. We also, the first thing it shows up at the top is t equals 0. So when we're going to be running the simulation, that's going to be the time that our circuit's running, and the time step is the time frame between every individual calculation of the circuit. So the first thing I want to do with our circuit is we want to do an example of a standard Ohm's law approach. We're going to make a power supply, and we're going to get it going through a resistor, and we're going to put in the power, and then we're going to check if that is correct with our Ohm's law calculations. So the first thing we need to do is we have to get us a power supply. We're going to draw. If we go to inputs and sources, we can say we're going to get a voltage source, a 2-terminal voltage source. We click that, and we drag up with the mouse, and there we go, we have our standard voltage source. Now let's see if I can zoom in on that. Let's get as large as, there we go. Okay, so we have this circuit over here. We have our voltage source. So if we hover over it, we see in the bottom corner, it says that VD equals 5 volts. So this is a 5 volt power supply. If we right click it, we can edit it. Press the edit button, and we can change that. We can change that to, let's say we want 12 volts, and so it's a 12 volt supply. You can also here change it to a variety of different options between direct current, so it's constant 12 volts. We can make it a frequency. We can make it simulate a wave, a pulse, or a noise, which is just being random information. So for example, if you wanted to make like a radio and you wanted to see if your circuit is able to transmit information even with like problems with the frequency or like the signal degrading, you can test your circuit in that way. But we just want to start with a nice simple DC and 12 volts, and we press apply. Okay. Now if we hover over it, we see it's changed to 12 volts. And there's currently 0 amps going through it, which makes sense because there's no, this is not connected. This is just like a battery. So what we're going to do, we're going to draw a resistor. Let's just get a standard resistor. We'll get one over here. Hovering over. Now over here, the resistor is this form of resistor, which is a, what would you call that? A zigzag-ish line. Under options, you can even change it to a European resistor if you want it to be a rectangle. You choose whichever way you want, whichever you want to visually represent your circuit, it's up to you. I'm going to keep it as this square. And let's just move this again to the center. So now we have our power supply and we have our resistor. If I hover over it, we can see some values. We have 0 current going through the resistor, which makes sense. It's not connected to anything right now. It has a 0 voltage drop, so VDs. We have, it has a resistance value of 1k ohms, so it's 1 kilo ohms. And then it has a power going through it of 0, because there's no power, there's no current or voltage going through it. If we right click it, again, we can edit it to change it to, let's say 1.5. Alright, so we've got a custom value. Now this is not connected together. Let's go to the wire, and let's connect this circuit together. We're going to grab from the nodes, and we're going to click and drag our wires. Bang, here we go. So now we have our circuit running. We can tell our circuit is running because we have these yellow dots going around. These are the visual representation of the current flowing through the system. So as we see here, we have our battery and the current is flowing up around, going through our resistor and back here to the power supply. We also see that there's a bit of color variation here. We have a green color. We have a green color over here. Oh, we can't see the mouse. We have a green color where the positive is of the mouse sensor. Let me just see if I can. Let me see if I can give us some sort of a mouse. Okay, it just doesn't want it. That's fine. What if I change it to? What if I change the color? Oh, that's slightly better. Okay, so we can see the mouse if I do it this way. So I guess we're going white now. So over here at the top, we see that we have a green, and then it stays a bright green. As soon as we get to the resistor, it goes to grey. If we hover our mouse to this over this point over here at the top, we can see over here our voltage is 12 volts. Okay, so far so good. If we hover our mouse at the bottom, we see we have 0 volts, which makes sense because this over here is the negative is like the 0 parts of the battery and the 12 volts is the top part. So the color green relates to the voltage going through the system. Now let's do our calculations. Let me load up. Let me bring this to the top. All right. So we have here some calculations. So we're going to do our Ohm's law, where we have V equals IR. This is a past equation, so let's just delete that for now. V equals IR is our Ohm's law, V being voltage, equals I is current, and R is resistance. Our voltage in our system, let's hover our mouse over, and we can see that our voltage is 12 volts. So we're going to 12 volts equals I. We don't know what our I is. We're going to find that out. We're going to prove that the system is working. We know that that is times by our R value, which is 1,500. All right, so I is then going to equal 12 divided by 1,500. So then I is going to equal, get a calculator, should equal 0.008. So that is 8 milliamps. Because that's 8 thousandths of an amp. And if we select our circuit, and we press any part of our component, because the current can only flow one way in this particular circuit, we can hover it and we can see our I is equal to 8 milliamps. So far, so good. The laws, it's good to know that your computer program that you're simulating observes the laws of physics and nature. Next, let's talk about the power. So we know our rules for power is power equals capital P power equals VI, and so power is going to equal our voltage is 12 times 0.008. We'll do our maths again. So it's going to be 12 times 0.008, 0.096, or power is measured in, this is measured in amps, and this power is measured in watts. So that is 96 milliwatts. And if we hover our mouse over it again, we see there our power is negative 96 milliwatts. Now, what that's saying is from this device is it is losing 96 milliwatts of power, which, so if you have a battery, it is releasing the power. The part of the circuit that's using the power is if we hover over the resistor, it is using 96 milliwatts of power. So if you want to think of it also like a light, your standard incandescent light is essentially like a resistor. It's just a coil of wire that's heating up. So this resistor is acting like that in a sense of it's using the power and it's converting that electrical power to heat. So that's our basis of our circuits over there. And so we know our Ohm's law works. I'm going to minimize the Ohm's law thing now. Okay. So we have our circuit and we're running a simulation, right? We have these squares going around. We have these options on the side that we can actually change. We can change the simulation speed. We see over here we have our t. So we've been running the simulation the whole time, and this t is equal to, it's just coming up to 4 seconds now. And so it actually takes processing power to do this circuit. So the time is never, it's not directly related. 1 second in our simulation is not 1 second in real life. But we can bump up the speed. We'll bump up the speed to the highest level that my computer is able to run it as. And we see there every second is approximately like about, it's about 2 seconds in real time, is about a second in the app. The next thing you have is underneath it, you have the time steps. That's, again, how many, that's microseconds or nanoseconds between how many calculation steps you want. So the smaller that is, the more accurate your device is, but also the longer it's going to take you to simulate a second because your computer has to run more simulations. Next we have the current speed. So as I toggle this up and down, I can change the rate at which the electrons visualize as they're flowing through the system. We can have to adjust this depending on when we have our we have a more complicated circuit because we're going to have areas of the circuit that require a large amount of power and areas of the circuit that require very little amount of, current that require very little current. So we're going to be adjusting this during watching our circuit so we can gain understanding of where the current is flowing through the system. Because if we see here, if we crank it up too high, it ends up being too fast for us to visually understand what's actually happening. It's like shuttering and looks like it's going backwards sometimes. It's just like a shuttering error. And then if we do it too slow, nothing shows at all. Alright, so let's start modifying this circuit and working with some interesting things. Let's just stop this simulation for now. Let's, over here, let's delete this wire. We're going to add two things. We're going to add a switch and we are going to add a light. So our LED light is going to be our output, LED. So we're going to click and drag. Now notice as I click and drag, it generates the image of the LED. And we know what that arrow and line means. It means over here, this is where the positive end of the resistor is. And over here is the positive end of the LED. And this is the negative end of the LED. So this end over here is connected to the negative. This end over here through the resistor is connected to the positive. So this in theory should work. Next, we are going to put an input. We are going to do we're going to do a passive component. We're going to do a switch. And we're just going to click and drag. And here we have a lovely switch. So let's start running this simulation again. We have a simple circuit. We see that LED light is turned on. If we press this switch, so mouse clicking it, we open it, and the circuit stops. So we can start to already make interesting circuits by doing this switch here. And we can go through. So that's the very basics of using the simulator. I'm actually going to cut the episode short here just so I can do another episode where we're going to be working on our more complicated system and we're going to simulate our circuit. Feel free with this app to look through the bunch of pre-done circuits. There's a more advanced version of Ohm's law showing here we have a 5-volt power supply going into two different resistors. Over here we have a 100 ohm resistor and we have a 1000 ohm resistor, and this over here is just they put a probe to measure the amperage in the circuit, and we can, for example, edit this and make that, if we make this 50, we can see that it's just showing the different amperage there, and that's got to be like drawing with like outputs and labels. We can like add an ammeter to measure the particular current going through a particular point, and we can do that. And this symbol over here is our grounding symbol. So it's going to be equivalent to our 0 voltage. So our voltage here is going from a +5 through this. You can play around with looking at other circuits on here, and some of them are quite interesting. Later we're going to deal with the 555 timer, and we're going to be using it to generate timing, but that'll be with a more advanced circuit. We're also going to be looking at using transistors. These are under our active components. We're going to be adding in transistors in the next tutorial to simulate our flicker tutorial. All right, we'll see you then.